we graphed the other day, we graphed polar coordinates, we graphed the dots, okay? And that's how we start graphing overall, and every time we learn how to graph, and that's like 6th grade, okay? Maybe earlier for some of us. I know my son Andy, who's in 5th grade, his teacher has him graphing points already. But we take that to equations next, right? We know if we put a lot of points together, we can connect them, and it comes up with an equation. Our first version of that is we draw a line, right? So this, I was reading this definition and I said, oh, wow, this is the same definition of a line, okay? So an equation whose variables are polar coordinates is called a polar equation. So basically, if it's got r's and thetas, you've got a polar equation, okay? The graph of a polar equation consists of all points whose polar coordinates satisfy the equation. It's the same. I could take out the word polar and put linear in there, right? That's the same definition that we have for a linear equation, okay? All right, so we're going to just plot the points. This is the way we start every single time we graph. We start with a table, and we just plug points into an equation, okay? Which is going to be interesting. Let's see. I'm going to do this a little, I'm just going to plug into this, okay? So I'm going to go 4 sine, and I'm going to do 0, okay? And see if I can get a value without doing the function. I don't want us to see what the picture quite looks like yet, so let's do, it was r. Wait a minute, what was our r? I lost my r. Hang on, I got to look again. Let's see, r is what we're getting. So it's 4 times 0, okay? And then 4 times pi over 6. So 4 times sine of 0. Okay, so I got 0. I'm going to fill that in my table, okay? So come back here, and we're going to put 0 in our table because that's what we got when we put in 0, okay? All right, let's do pi over 6 next. So all I'm going to do is replace that 0 with pi divided by 6. I got 2. All right, now I'm going to do pi divided by 3. It's not like we've never done this before, right? We've done stuff like this, just not with polar equations. All right, so pi over 3 I got, and I'm going to go ahead and use the decimal point for now, okay? 3.464. 3.464. All right, pi over 2. Got a 4. Okay, so here's what I want you to do. I want you to fill out the rest of the table, okay? So you fill out the rest of it. Use Desmos, get those last 3 values, figure out what the decimal points are, okay? A few more seconds. Make sure you've got those 3 points and the values written in your table. Okay, that's what I got. Do we agree? Yeah. Okay, so now we're going to plot those just like we did. We plotted polar coordinates last week. Okay, so I'm going to go in order, and that's how I would connect this too. Is I'm going to connect it in the order that I draw it. Okay, so I'm starting with 0, 0, so I'm at the pole. Okay, and then I'm going to go pi over 6, 2. And it looks like I have a pi over 6, pi over 4, and pi over 3 line, right? That's what they gave me on this graph. So I know that this first spoke is pi over 6. So I'm going to count, how many rings am I going to count out? 2. Okay, so I'm going to go out 2 rings. Now I'm going to go out 3.4 rings, right? So about 3.5. We're just going to estimate that. And we're on this pi over 6 or pi over 3 line. So 1, 2, 3, and about halfway. And then pi over 2 is at 4. And then 2 pi over 3 is at 3.46. So it should be at about this same spot on this line here. And you're going to start noticing that there's a lot of symmetry involved in this, okay? And then we're going to go out 2 rings on the 5 pi over 6, which would be here. And then we're back at 0. And we're going to go ahead. It doesn't look perfect, but we're going to go ahead and connect those the best I can. Oh, I'm missing. Totally missed one dot. That's close. What did I just draw a picture of? It's a circle, right? So what we just drew was a picture of a circle, okay? We have equations for circles in the rectangular world. It's not something I've taught you, but we know they exist because it's a piece we skipped the last couple of years. But there we can also draw circles in polar, okay? And we're going to basically draw kind of variations of circles. Polar graphs are very curvy, okay? And they're not actually, well, if we use the vertical line test, they will all fail the vertical line test, okay? They don't look like a normal function looks, okay? All right. If a polar equation involves only r equals a sine theta or r equals a cosine theta, your graph will be a circle. Can you describe the direction? Okay, so here's what we're going to do in Desmos next. Okay, actually, pull up one thing really quick. This, but I'm going to hold on. I'm putting my answer key over here so I don't make sure I mess this up for you guys. Okay, so let's experiment with this a little bit. Okay. So I want to know what happens when I have r equals positive or negative. So plus, I'm going to use a different color for minus, plus or minus a cosine theta. And I want to know what happens when I have r equals plus or minus a sine theta. I want to know if there's some symmetry. I want to know if it's going to be on the left or on the right or up or down. So that's going to hopefully become obvious here in just a second. So let's put this in our calculator. So let's just pick a number for A. I'm going to pick 2. Okay. So I'm picking an A value, and I'm just going to use the same A value on all of them and change the signs and change the cosine or cosine part. Okay. So everybody do this with me. Okay. So you're in Desmos. All right, so I'm closing that off, and I'm going to say r equals, let's start with 2 cosine theta, and just start typing the word THEATA, and it will pop up, or down here, this thing is in the way. Down here, there's a little keyboard, and my guess is that theta is hiding in here somewhere. Maybe, is it under A? It's not under ABC. It's probably under functions somewhere. And there might be some Greek letters somewhere. Maybe not. I guess not. Just start typing the word theta, apparently. Just like we can type the word pi. I don't know why they're not popping up. Okay. All right, so T8, it was, what was it? THETA, and it'll pop up to a theta. Okay. So notice, what shape did we get? We got a circle. Okay. Is it to the left, to the right? Is it up? Is it down? What do we notice about it? It's to the right. Okay. And what's our line of symmetry right now? What axis is this one right here? That's the x-axis. So it's symmetric about the x-axis. Okay. So we know that cosine it looks like cosine might be symmetric about the x-axis. We're going to look at that here and again in a second. And when it was positive, it went to the right. Okay. So let's look and see what happens if we switch that to negative. So r equals negative 2 cosine theta. So I'm doing those separately. Okay. All right. So what happened? Is it still symmetric about the the x-axis? Yes. Okay. Is it to the left, to the right, up, down? To the left. Okay. Perfect. All right. So let's record what we just did there. Okay. Let's put that in our notes here. All right, so for cosine, we just learned that it has x-axis symmetry. Okay. If A is positive A means we are on the right. Whereas if we had negative A, we are on the left. Positive A on the right, negative A is on the left. Okay, let's go back here again. Now we're going to close those two out. Let's look at whatchamacallit. Let's do sine. So r equals 2 sine theta. Theta. All right. What do we notice about its direction? Left, right, up, down? It was up, okay. And then what about its symmetry? What kind of symmetry? It's y-axis symmetry. Okay, so we've cosine, we have y-axis symmetry. All right, let's try doing the negative. R equals negative 2 sine theta. What do we notice? Up, left, down, upright. Down, and then what kind of symmetry? Y-axis. So hopefully we've discovered that sine has y-axis symmetry, cosine has x-axis symmetry. Understanding that can help us when we try to graph these things, and I don't have to maybe plot quite as many points because I can use symmetry to do the rest of the plotting for me. Okay. All right. So let's write that, summarize that a little bit. So we know that we have y-axis symmetry with sine. Y-axis symmetry. Okay. If it's positive A, it is up. Or if it is negative A, it is down. Okay. So we're gonna write out some notes on how to figure out this symmetry stuff, verbal or the long way, and then I'm gonna show you the shortcut. Okay. This is in your backup plan here, is if the shortcut doesn't work for some reason, we could use this. Okay. So in order to graph other polar equations, so more than just a circle, because there's lots of different ones, okay, we often have to plot sample points. Testing for symmetry will make this easier. So we can simply replace r and theta with some things, okay? This says that what we're going to test it, what that means verbally, and its symmetry. This is an abbreviation for with respect to. Okay. We've talked about that a lot, right? With respect to the x-axis, with respect to the y-axis when we were doing volume. Okay. All right. So one thing we can do is if we replace the theta, okay, with this pi minus 0, and we end up with a negative r and a negative theta. Okay, so this is what we're replacing with. This is what the answer would look like. Okay, so verbally we would replace theta with pi minus theta. If we end up with negative r and negative theta, we have y-axis symmetry, or, okay, we have symmetry across the line, or the theta equals pi over 2. Okay. So one of those two things, because they're the same. It depends on if we're rectangular, if we're in a polar graph or a rectangular graph. Okay. Okay. If I happen to replace the theta with just a negative theta, and I end up with something that looks like that, so we're going to replace theta with negative theta. That's how we end up with x-axis or polar axis symmetry. Remember, the polar axis is the x-axis in the polar graph. Okay, and then the last one is if I replace the r with negative r and I end up with this answer, okay, I get origin or pole symmetry. So replace r with negative r, I get origin or pole symmetry. All right, that's quite a lot to remember though, right? And it's a lot of looking at angles that might not be super obvious when we test things. But if we had to, we could go and do that, okay? So it says that the 3 tests are sufficient to guarantee symmetry but aren't necessary. That is, if a graph fails a symmetry test, it doesn't mean it's not symmetric, but if it passes the test, it must be symmetric. But there's some quick tests, okay? We just experimented with it, right? We learned that if we have a function that has a sine in it, it's symmetric to the y-axis, right? That's what we wrote down up here. Sine was had y-axis symmetry. Whereas if we have a function that has cosine in it, it is symmetric with the x-axis, and that's what we talked about right up here, right? Cosine went with x, which doesn't surprise us, right? Isn't cosine always go with the x and sine always go with the y? So that shouldn't surprise us. So we can use that nice little shortcut again, okay? All right, so we're going to try to spend a few minutes understanding a pattern and trying to write it down, okay? And you're going to get to see what some of these graphs look like in that pattern, okay? So they give us a new name of a type of polar graph. It's called a cardioid, okay? And it ends up being one of these two functions. Either we have r equals a plus b times cosine theta, or we have r equals a plus or minus b times sine theta. Depending upon the values of a and b, that gives us different pictures of graphs, okay? So we're going to write down what those different pictures are. We're going to experiment in Desmos for a few minutes, and then we're going to work on plotting a little bit by hand, okay? The first one, let's see, does this do enough? Let me look at the plotting by hand part here and see if I get enough. Do they experiment with one of each? Sine, cosine. Yeah, sort of. Can you explain the pattern? Give me just a sec. They do that one. Okay. All right, so if I get something, we're just going to use the ones that are down there below. Okay, so we're going to see if we can get the pattern based off of these graphs rather than doing a lot of extra things. Okay. So the first one is we have that the a and the b value are equal. So notice our a and the b value are equal on both of those. The absolute value of them would be equal. So let's write down that as our first pattern. So a over the absolute value of a over b equals 1. Okay, so we're going to try to figure out what that looks like. So let's put in, we're going to put these into Desmos just to look at it. And if we want to, we can switch to the polar graph. Okay. All right. So I'm going to go ahead and let's put in the 2 plus 2 cosine theta. Okay. All right. I'm going to close these out. I'm going to switch to the polar graph so we can kind of graph it a little bit better. So we did graph one by hand with the points. We're going to probably use our graphing calculator to help us on the rest of them here. So r equals 2 plus 2 cosine theta. Okay. What does cardioid sound like? Cardiac, right? Cardiovascular. And what does that have to do with? A heart. So what does the picture look like? Kind of looks like a heart, right? So, well, yes, it kind of looks like that too. Okay. But you can kind of imagine heart. There are ways we can actually get it to graph a heart. But it kind of looks like a heart. Okay. All right. So that's our picture. What do you notice about the symmetry? What's it symmetric about? The x or the polar axis, right? Because that's our polar axis now that I switch it to a polar graph. Okay. We know that is the cosine, is it positive or negative in front of the cosine? Plus. Do you know how it went to the right instead of going to the left? Remember we talked about that? If I just did this, this isn't the picture that we have, just watch. Okay, so if I went and switched that, look at what happened. Do you see how it went to the left? So all I literally have to do is change that sign and it determines if it's left or it's right. Okay, all right, let's go ahead and plot that. Okay, so I'm going to try to plot. Let's see, it looks like there's a point here at 0, 0. There's a point out how many? 1, 2, 3, 4 rings out. Okay, let's start there. I'm going to start with those because I'll forget if I go more than that, right? So I have a point here. Oh, maybe I don't. I'm on something that's not drawing. Okay, I have a point here. and I have a point 4 rings out. And then let's see if I can at least, let's see what's on the pi over 2 axis there. Let me find my calculator again. Okay. Let's see. It looks like here we're out 1, 2 rings. That's pretty good. And then at pi over 3, it looks like we're at 1, 2, 3 rings, right? So let's try plotting those 2 points on there. All right, so we're out 2 rings here, and at pi over 3, we're out 3 rings. I could use symmetry, right, to plot my other side, right? Because it should be here. And if I were folding across, it would be there. All right, that should hopefully be enough for us to be able to sketch it. Okay. I'm going to use a different color to sketch just so that we can kind of see it. I know it dimples out from here. It kind of makes that heart shape all the way to there, and then it comes right back around. Okay. Mine's not quite as pretty as the Desmos graph. It shouldn't have any points on it. It should all be curvy. Okay. Let's talk about the symmetry. So you already told me it's symmetry about the x-axis, or if we're going to be technical about this, since we're on the polar graph, we'd call it the polar axis. Okay. Our ratio that we got was that A over B equaled 2 over 2, which equals 1. Okay, because that's going to tell us a lot. It tells us that it is what we call a cardioid. Okay, so we know that this is, when we have the ratio equal to 1, it's a cardioid. Okay. And then we also understood that it was a positive cosine. So that made it fall towards the right. Made it go to the right. Because we also kind of looked at the negative cosine, made it go to the left. Okay. So knowing what we know about that, and knowing what we've learned a little bit about sine, okay, and cosine, I basically have the same thing, but I put a negative in front of it, right? And then I swapped out the sine for the cosine for sine, all right? So does it have the same ratio? The ratio is 2 over negative 2. Do we end up with the same ratio? Yeah, it's still 1. So that is our determining factor that should be a cardioid shape again, okay? Well, is it going to go in the left-right direction or the up-down direction because it's sine? It's going to go up-down. Okay, good. Is it because it has a negative in front? Is that going to make it go up or make it go down? Down. Okay, so let's see if we're right. Okay, let's see if we're right. Let's put that into Desmos and see if we guessed right. Okay. So we've got 2. I'm switching this to a minus. And then I'm going to switch this cosine to a sine. Some other interesting things pop up when you do that, right? All right, were we correct? Yep. Okay, so now I just have to sketch this one. So I'm going to kind of use my symmetry again. I know I'm at 0. I'm out 1, 2, 3, 4 rings. Okay. And then let's see, we're out 1, 2 rings there, and 3 rings at pi over 6, or 11 pi over 6. So let me see if I can recreate that here. Okay. All right, so we're here, and then at pi over 3, we were out 2 rings. We were out 3 rings. I take that back. I was not out 2 rings there, was I? I am have to look again. I know I was out 4 rings here. I'm going to go back and look. Okay. And then let's see. We were out 2 at pi over 6. And then 3 at 0. Right? So 2 at pi over 6 and 3 at 0. Okay. 2 at pi over 6 and 3 at 0. There we go. And I'm going to use my symmetry over here. 2 at 5 pi over 6 and 3 at pi. If I really wanted to, I could get another one in here, but I probably know enough about it that we could probably sketch this. So we're doing something like this. Curves around. This time our symmetry would be at pi over 2, right? Because it's symmetric about this pi over 2 axis, which we used to call the y-axis when it's rectangular. Okay. Okay, let's see if we can just finish this page. Okay, and we'll just finish the cardioids today, and we'll see how that's going. I have to put out some homework out there probably. We'll see how long that takes us to do, and then we'll work on the next two tomorrow probably. Okay. There's like 4 or 5 different types of graphs that we get here. All right, let's talk about. So the next one, let's look at the ratio on the next one first of all. So because we're going to get a different type on this one because they're not equal to each other this time, right? So my ratio is going to be 3. My A over B is going to be 3 over 2. That number happens to be greater than 1 and less than 2. Okay. So there's going to be something that happens when my ratio is greater than 1 but less than 2. Okay. So if I know I am between 1 and 2, okay, we get a different, whatchamacallit, we get a different type of graph. So let's see what happens this time. Okay. What was my picture of? 3 plus 2 cosine theta. So 3 plus 2. If I'm cosine, notice I just got a circle, right? I'm cosine, am I going to be symmetric across the polar axis or across pi over 2? Polar axis. So I'm expecting this to be, and it's positive, so should it be on the right or the left? Should be on the right. Okay, so let's see what happens. So cosine theta. Awesome. All right. This is, notice it's not a point in. It didn't come to like that sharp point. It's kind of just dimpled. Okay. We call it a dimpled limacon. Okay. And it's got some weird, let's see if they have one. Oh no, she just spelled it normal there. It sometimes has some weird, funky notation looking stuff, but we're just going to write down dimpled limacon. Okay. All right. I don't know who came up with any of these names. So dimpled limacon. Okay, so when I have that ratio between 1 and 2, I have a dimpled limacon. Okay, I didn't write that down the last time, did I? We'll fix that up. Okay, so let's take a look at plotting that. Okay, so the first thing I'm going to do is look at, I'm going to go back to my graph. Okay. It looks like I have 1 out on the pi and 5 out on the 5 rings out on the 0. So let's start there. So 1 out on the pi and 5 rings out on the 0. 1 out here and 5 out there. Okay. Then let's see what else I got. Let's see. Out at the other poles or at the other axes, it looks like I'm out 1, 2, 3 rings. Okay. And then it looks like 4 rings at 5 pi over 3 and pi over 3. So I'm going to use those to kind of help guide me. Okay. So I'm out. I totally forgot. What did I say? See, I'm just like Dory. 3 and 4, right? Okay. That's what happens when you have 3 children or 4 children at home. See, I even forgot how many children I had there just for a second. Dr. McGowan asked us for personal celebrations for, the staff meeting this week. And she only left us 3 spots. How was I supposed to do that? I've got 4 kids. I filled in one of the spots with two answers. All right, then let's see. There's one more thing that might be able to help me. I'm going to go back and look at that one more time. Kind of wanting one over here to help me. Oh, go back. All right, so I'm kind of wanting maybe at 2 pi over 3, it looks like it's out 2 rings right there. So I'm going to try that. Okay. 2 pi over 3 is out 2 rings. So that might help that little bit of a, showing that little bit of a bump right there. Okay, I'm going to try to sketch it now. Kind of looks like nothing right now. All right, so I'm starting in here kind of at the center. I know I'm bumping out all the, oh, I missed. I'm going to do that again. I know it's got to make like a dip in here. Bumping out. It's supposed to dip a little bit in there. Okay, so our symmetry should be, we said that was the polar axis symmetry. The other thing we didn't write down on the last one that I forgot is it was positive cosine, right? So the pattern is that it goes to the right. I forgot to write down, and this is more just for your own stuff, right? This one was a negative sign, which made, say, it go down. Okay, let's see if we can predict a little bit. Let me go back up here and look a second. Okay, this one, oh, this one's going to be a little bit different. Okay, so first of all, if I'm in sine, what should my symmetry line be? Is it going to be the polar axis, or is it going to be pi over 2? It's going to be pi. So my line of symmetry should be pi over 2, right? Okay, if I'm in sine, and am I positive sign or negative sign? Negative in front of the sign, right? So when I have negative sign, oh, why am I spelling sign wrong this morning? I don't know what's wrong with my brain. All right, am I left, right, up, or down? Down, right? Negative, sine is up and down, cosine's left and right, and negative sign would be down. So I know it's going to be down here somewhere, right? That's where my graph is going to land, okay? My ratio this time, my A over B, though, is going to be 5 over 2, which is greater than 2 this time. So something else happens when it's greater than 2, okay? So we're going to write that down up here. Okay, so we have A over B is greater than or equal to 2. We're going to have what we call a convex limacon. Okay, so let's see what that looks like in Desmos here. Okay. All right, so let's take a look here. All right, so we've got, it was 5, or R equals 5 minus 2 sine theta. Look at that, I remembered it without even having to look. Okay. So we were correct in our predictions, right? It looks like I am up 1, 2, 3 values that way, 3 rings that way, 1, 2, 3, 4, 5, 6, 7 rings down. Okay, so 3 up, 7 down. Let's start there. Okay. So 3 rings up, 7 rings down. All right, I'm going to go look at my left and my right now. Let's see. I am out 5 rings to the left, 5 rings to the right. That's probably enough for me to probably graph it. Okay. 5 rings this way, 5 rings that way. And I know it's supposed to look a little bit more like an awkward looking circle, like Davy sat on the circle. Okay. All right. Because that's what my 4-year-old would do, is he would try to sit on something like that. It's an awkward looking circle. Okay. Let's see if I have anything else. We already did that. Okay. There is another pattern that exists here. So let's see if we can recognize it a little bit, since we've already got these graphed and we just have a few minutes. Okay. So there's one other way. We didn't necessarily, what if we didn't have the calculator to help us out and we wanted to find those values that we plotted without having to do a t-chart? Okay. So there was actually a pattern to what was going on, okay, on your axes. So we're going to write that up here. If we have A minus B and A plus B give axis values, we're going to try it out, okay? And then A is also an axis value. So let's see what happens with that, okay? We kind of did it with the graphing calculator to help us, but let's see if that's actually true, okay? And if that holds true on all of them, okay? Okay, so I'm going to go back and I'm going to look at A minus B, A plus B, okay? Well, let's see. A minus B equals 0 on this one, right? Because A minus B would have been 2 minus 2. Do we agree? 2 minus 2 equals 0. So was that one of our values that we had on our graph? Yeah. Okay, so then we would have had A plus B, which equals 2 plus 2, which is what? 4. So I had 4 rings out on this axis. Okay. And then let's see if the other value was what A equaled. What did A equal? So do you notice how we had a value of 2 on both of those axes, the one that was repeated? Okay. All right, let's see if we can find a pattern of when we use A minus B and A plus B and which axis it kind of lands on. Okay. All right, so on this one, if I did A minus B, which that would be 2 minus negative 2, what does that give us? Gives us 4, right? Was that one of our values? 4 rings out? Yeah, okay, and then if I do A plus B, that would give me 2 plus negative 2, which gives me 0, right? Which was one of our values. And then what was our A value? 2. And then notice there were the 2's on the other axis, right? So right now it looks like this A plus B and this A minus B, those are the values on your symmetric axis, right? And the A value is on the one that doesn't have the line of symmetry on it. All right, let's see if that holds true, right? So we just said that this goes on the axis of symmetry, on axis of symmetry. And then this is the other axis. So let's see if that holds true for the other ones, right? Because that worked great on the ones where they were the same. Let's see if it works on the ones that aren't the same. Okay. All right, so A minus B on this one would be 3 minus 2, which equals what? 1. Was that on the axis of symmetry? It's our polar axis, right? Okay, so that held true. So A plus B equals 3 plus 2, which is how much? 5. Oh, look, did it work? It's looking pretty good. All right, and then our A value was what? 3, and notice that was on our non-axis of symmetry. Okay, let's try one more here just to check it out. So A minus B on this one would have been 5 minus negative 2, which is how much? 7. Is that one of our values? Is it on the axis of symmetry? Yeah, that's pretty cool. Okay, so A plus B would have been 5 plus negative 2, which is how much? 3. Okay, so I'm up 1, 2, 3. Did it work? And then our A value is what? And that was on our non-axis of symmetry. Okay, so hopefully we've recognized some patterns. I know it was a lot of just plotting and kind of doing the same thing, but we're not intending to go fast through this, so we want to make sure we understand it. Okay. All right. You already right now, three days into this, have a better understanding of polar than my BC students do right now. So they did not get quite this detail. All right. So that's where we're going to stop today.